This is proof 24, the last proof on the study guide. When you look at proof 24, there is just so much stuff to think about here. I know that this one can be kind of intimidating. Let's read this proof and think about what we know already. So we're given that segment FR is congruent to segment AN. When you look at the diagram, that is not marked on the diagram. It's true because it's in the given statement. Go ahead and mark it. Let's go ahead and say that FR is congruent to AN. Oops, that kind of looked like a J. My stylus just slipped. Okay. I think sometimes when we mark it on the diagram, that makes it a little easier for us to see some of these relationships. All right, take a moment. You might want to pause the video, write down everything you can in your thinking space. Hopefully you paused. I'm going to tell you right now what I'm thinking about. And this one's going to be, this one's a doozy. All right, so I know that FR and AN are congruent. I also know that means that their measures are equal. So the length of segment FR is equal to the length of segment AN. That's probably going to be important to us later. I notice, and I'm going to kind of write over the picture if that's okay. I notice that segment FA is the same as FR plus RA, because segment FA is ultimately part of our final proof. I also notice that RN, which is something we're proving, that segment RN is made up of AN, which is again from our given statement, plus that segment RA. So that might be really important to me to notice that those appear in both of those statements. I'm thinking that somewhere in my proof I'm going to be using segment addition. I might write unit 1.1 because it reminds me of that. Something else I'm thinking about is that there are no values here, so I'm not expecting to use any algebra because I don't have any numbers or variables that relate to the lengths of any of this stuff. So this is going to be a really conceptual proof here. I know that I've got congruence, so I might be thinking about the definition of congruence and what that can tell me. And again, it's really standing out to me that I have RA and those two different equations. So this is a tough one. So let's go ahead and put it together and see what we can find out about this proof. All right, our first statement, man, if you looked at this and you were like, I don't even know where to start, that's not true because we always start, we always start with our given statement. So I'm going to write segment FR is congruent to segment AN. Why? Because it's given. That's at least a point right there. That's part of our proof. Okay. We said over here that we might be combining other parts of this segment. Like we're probably going to have to add this to FR to eventually get segment FA. When we do that, we're going to add the lengths of these segments, not adding the segment itself. So I think we need to take this from a statement of congruence about the segments to a statement about equality about the lengths. And this might not be intuitive to you, but I'll tell you it is important. So we want to then say that, because remember, we're trying to build the most sound case that we can. We could say that the length of FR is equal to the length of segment AN. And we do that without using the segment notation, but the distance or length notation. All right, how do we know that? Well, that's the definition of congruent segments. I'll take the definition, sorry, my stylus slipped. I'll take the definition of congruence here. You don't have to say congruent segments. Congruence. Okay, so again, the definition of congruence tells us that when two segments are congruent, their measures are equal. That's the definition of congruence. All right. Now, let's think about what else might be important. If you were following kind of what I was thinking over here, I said that we have segment FR. We're eventually trying to get to segment FA. Same is true with AN. We're trying to get to RN. And if you look, the thing that needs to be added to both of those is segment RA. So before I can really do anything with the length of this segment, because I intend to use it twice, and again, this step might seem really counterintuitive to you, but we need to establish that RA is equal to itself. So again, you might be like, what? Of course it's equal to itself. Well, in a proof, you really have to establish that. So the length of segment RA is equal to the length of segment RA. And again, we're going to be using RA in two different segments. So this really is kind of a necessary statement, even if it feels kind of weird to write that. Remember, it is that reflective property or reflexive property of equality that lets us say that the length of RA is equal to the length of RA. Now you might be like, what? Why in the world do we need that? Well, let's see what happens. Now in step 4, we're eventually trying to add FR and RA. We can do that now, and if you look at step 4, I think you'll see why. So I'm going to actually look back at step 2. We're going to take our statement from 2, we're going to repeat it in 4 because we've already established that it's true. We're going to repeat it in 4 and we're going to add RA into it. So we're going to say FR, so the length of segment FR plus RA is equal to the length of segment AN plus RA. This is why in the last statement I wanted you to say that RA equals RA, because we're using it twice now. What is it that allows us to add the same thing to both sides? That is our addition property. So addition property of equality, or just addition property. All right, now if we think about this, we've added the same thing to both sides. Over here in our thinking space, we said that when we add FR and RA, we get this length FA. And hopefully we recall that that's the segment addition postulate that lets us add segment FR to segment RA. So I know I'm kind of going back and forth using segments and distances. Since we're talking about equality, we're really talking about lengths here. So we're going to keep it, we're going to keep the notation not as segment notation, but the lengths of the segments. All right, so in statement 5, so I now want to basically take each half of statement 4 and break it down into statements 5 and 6. So let's start with the first half of statement 4. We said that we're going to add FR and RA. So FR plus RA equals the length of segment FA. Why is that? That's because of our segment addition postulate, and I am abbreviating here. For statement 6, we're going to do the same thing but with the second half of this statement. So we could say that segment AN plus RA, you could have put RA in front, is going to equal segment RN. And if you're looking at the diagram, so we just said AN plus the segment RA equals RN. The reason I'm keeping the name RN instead of like NR is because up here in our proof we want to get to segment RN. I don't know, it just makes it easier in my opinion. All right, and we said again that's the segment addition postulate. Really abbreviating here. All right, now let's take a look at what we have. I'm going to attempt to highlight this. So we said that FR plus RA gives us FA. Whoops, that is not a highlighter. Gives us FA. And that when we add AN and RA, we get RN. So now, the reason I highlighted those is because if we go back, we can now substitute this for all of this from statement 4, and we could substitute this for all of this in statement 4. And I just used the word substitute twice, so that should give us a hint about our reasoning. All right, in number 7, we're going to substitute FA. I guess it doesn't, well, yeah, we want to keep our equation looking the same. So now we could say that the length of segment FA is equal to the length of segment RN. And again, this is the substitution. Don't write on your statements like I'm about to. This is just for illustration. Don't do this in your proof. But we're putting FA up there and we're putting RN there. So we're substituting what we get in 5 and 6 for what we had in line 4. And again, we said that's going to be substitution property. And then lastly, oh, we're so close, light at the end of the tunnel. If we can say the lengths of FA, segment FA, and the lengths of segment RN, if those lengths are equal, that means the segments are congruent. And this takes us back to how we started this proof, that we can use our definition of congruence. And you are done.